The Fibonacci sequence starts with 0 and 1, and after that every number is the sum of the 2 before it. So it goes 0, 1, 1, 2, 3, 5, 8, 13, and on. We want the nth number in this sequence. Its definition literally refers to two smaller Fibonacci numbers, which makes it a perfect example of recursion that calls itself twice. The rule is right there in the definition. The nth Fibonacci number is the sum of the 2 before it, fib of n-1 plus fib of n-2. So we make two recursive calls and add their results. The two smallest cases are given directly. Fib of 0 is 0 and fib of 1 is 1. And those are our base cases that stop the recursion. Every call reaches for smaller indices, so both branches march down toward 0 and 1, which means it always terminates. If n is less than 2, it is either 0 or 1, and in both cases the answer is n itself, so we return it. That single line covers both base cases. Otherwise, we return the sum of fib of n-1 and fib of n-2, the two smaller Fibonacci numbers. Let's write it and check a few positions in the sequence. The base cases together. For n of 0 or 1, the answer is just n, and that stops the recursion. The recursive step, we add the two Fibonacci numbers just below n. Now let's test it and hit run. There we are. Fibonacci of 0 is 0, of 1 is 1, of 7 is 13, and of 10 is 55. Each answer is the sum of the two just below it. The flow is small. If n is 0 or 1, return n. Otherwise, return fib of n-1 plus fib of n-2, and each of those calls branches down toward the base cases. Here is a warning. Because each call spawns 2 more, the number of calls roughly doubles with n, so this plain version takes about order 2 to the n time, which is exponential and gets slow fast. The space is order n for the deepest path in the call tree. In practice, we speed it up by remembering answers, called memoization, or by using a simple loop, which brings the time down to order n. 3 things. First, you need both base cases for 0 and for 1, or the two branches never bottom out. Second, this simple version recomputes the same Fibonacci numbers over and over, which makes it exponential and painfully slow for larger n. And third, for anything beyond small inputs, remember past results with memoization, or just use a loop that keeps the last two values.